Welcome back to Botronix Labs. In this video, we'll guide you step by step through assembling your very own 3D printed Otto-style robot car powered by a Raspberry Pi Pico. This robot is based on the open-source DIY Otto project, licensed under CC BY. So big thanks to the OttoDIY robot community for making the mechanical design freely available. Make sure you've got all the required components. Raspberry Pi Pico. Two 360-degree servo motors. Ultrasonic distance sensor, HCSR04. Active buzzer. 7-segment LED display. Green LED with resistor. Sliding power switch. Battery pack. Jumper wires and ground connector. 3D printed Otto body, head, motor clamp, wheels, and caster. Some screws, nuts, and screwdriver. In this step, we'll install the two continuous rotation servo motors into the 3D printed Otto robot body. In this build, we've removed the original buzzer holder. This gives us more space to mount the motors properly without obstruction. Slide the motor into place gently. It should be snug but not forced. Repeat the same process with the right side motor. Fix the motors with the motor clamp. Use 2 screws per motor if your design has mounting holes, or hot glue if you're prototyping quickly. Make sure both motors are level and flush with the chassis before moving forward. In this step, we'll install the wheels onto the continuous rotation servo motors we just mounted in the Otto robot body. First, grab the tool parts. Make sure they're clean and free from any 3D printing residue. If the wheel has a hole designed for the servo horn, ensure it matches the size of your servo shaft. Light bulb before attaching the wheel. Double-check that the servo motor shaft is properly aligned and rotates freely. You can turn the shaft gently by hand if needed. Now, locate the cross-shaped or circular servo horn that came with your servo. If it's not pre-installed, attach the horn to the wheel using small screws or by pressing it firmly into the wheelbase, depending on your design. With the horn attached to the wheel, align it with the servo shaft. Press the wheel onto the shaft until it fits snugly. Then use the central servo screw to lock the wheel in place. Repeat the same process for the other side. Now that the main drive wheels are installed, it's time to add the caster wheel to balance and support the back of your Otto robot. The caster wheel lets the robot pivot and roll smoothly on flat surfaces. It's essential for stability when turning. Check the orientation of the caster base. Align it with the mounting holes at the rear bottom of the Otto chassis. It should sit flat and centered between the 2 drive wheels. Insert the caster into the printed socket or snap it into place if it's a press-fit design. If your model uses screws, use small screws to secure the caster base to the chassis. Tighten the screws just enough to hold the caster firmly in place. Don't over-tighten or you might crack the 3D print. With the caster installed and the robot taking shape, let's now install the active buzzer, used for sound feedback and obstacle alerts. In our build, we removed the original buzzer holder to make space for the servo motors. So instead, we'll glue the buzzer between the motors, directly onto the chassis. Now let's move on to installing the 7-segment LED display, which we're using to show emotional expressions on our Otto robot. Start by placing the display horizontally, rotated 90 degrees counterclockwise from the standard vertical layout. Now it's time to install the sliding power switch, which will control power delivery from the battery pack to the rest of the robot. Locate the switch slot on the 3D printed body, typically near the back or side of the robot. If your design doesn't have a dedicated switch holder, you can use a small dab of hot glue to secure it in a convenient, accessible location. This switch adds convenience and safety, letting you quickly power the robot on and off without unplugging wires. Now let's install the ultrasonic distance sensor into the head of the Otto robot. This sensor acts like the robot's eyes to detect obstacles in its path. Now it's time to install the power system inside Otto's head. First, take your 2-cell battery pack. This will be used to power the main system, including the Raspberry Pi Pico and servo motors. Next, take your 1-cell battery pack. This one will power the ultrasonic sensor independently. On the screen, you'll see the full wiring layout for this project. Make sure to double-check your connections before powering on the robot. This circuit diagram will also be available in the video description or course resource files so you can reference it while building. Now it's time to see our Pico Otto robot in action. You've successfully put together all the key components, from installing the servo motors and wheels, to mounting the ultrasonic sensor, buzzer, sliding power switch, and 7-segment LED display. We also wired everything neatly with a clear circuit layout and placed the battery packs securely into Otto's head. This assembly lays the foundation for programming and testing, giving your robot both structure and functionality. If you followed along step by step, your Otto robot should now be fully assembled and ready to be programmed in the next tutorial. Thanks for building with us at Botronix Labs, and we'll see you in the next video, where we bring this robot to life with code.